Hi, yeah, this is fundamental or elementary particles explained. There are three generations of matter: quarks, leptons and bosons. Quarks: up quark, charm quark, top quark; down quark, strange quark, bottom quark. So then you get up, down, charm, strange, top, bottom. Okay. Then we have the leptons. We have electron, neutrino, muon, neutrino, tar, neutrino, electron, muon, and tar. So you have leptons, and we have photon, gluon, weak force Z, and weak force W. And the Z is a zero. A reference point, and the W is a plus or a minus. Okay, so in particle physics, elementary particles is a small thing which is not seen to have an internal structure, sort of like an atom. It's got a neutron and a proton and an electron. Okay, these quarks, leptons and bosons, they've got no internal structure like that. They are electromagnetic forces without any known internal structure. So they're believed to be the basic building blocks of the universe. This is science as it stands right now. Right, the CERN Hadron Collider is about to explore leptons, quarks and bosons. The Higgs, you might have heard of it as the Higgs boson particle, might have heard it referenced to. And they're going to literally smash atoms and photons and protons and neutrons and all these things together, and they're going to explore the small particles, quarks and what have you. This, they hope, is going to reveal the structure of the universe. Fermions, bosons and all the manner of things. So fermion is the quark and the lepton, and the boson, so they reckon there's three flavours of these extra small particles. Okay, now in my theories, which I've been posting online recently, I've been referenced to small things. Okay, small particles, small things. Now these are individual items which make up, I'm guessing these are individual items that make up the field strengths of the fermions and the bosons. And when I say ST, I don't mean string theory. I'm not talking about the string theory here, the string theory. But again, with the string theory, you can't explain how life started from nothing. The only way you can explain how life started from nothing is through a rudimentary particle. When I'm explaining a quark, you've got to imagine, we think there's like 7 quarks and 5 leptons inside the proton inside the nucleus, actually, inside the nucleus of an atom. That's how small these things are. Alright, and the things that I'm talking about are like wisps, little nothings in comparison to the size of a quark or a lepton. Okay, and these things that I'm talking about, which I'm referring to as small thing, are capable of mitosis. And that is the only way that you can explain everything. That's the only way that you can explain all and everything. You've got to imagine that space is what we live in. Right? You call it 3-dimensional space, I call it 16-dimensional space, with the possibility, I'm thinking, that there might be 24 dimensions in my theories, right, which I'm going to be posting on the internet, or longer, depending on how quickly I get it done. Quicker if you help me. And the small things you have to imagine that we live in 16-dimensional space, okay? And 16-dimensional space is expanding in something, right? But that something that it's expanding within is limitless, and there is nothing to stop us expanding. But in that vast nothingness, it is possible for a small thing to become, to sprout, to spontaneously be created, right? And the only way I can explain the first thing ever, and it's extremely small, right? It's way before any kind of explosions like the Big Bang. The only way I can explain it is you've got a vast nothingness with no pressure, nothing at all, no light, no dark, just nothing. And space is expanding into it. Okay? Now space has dimension and has limits. Our universe has limits. When you get to the end of our universe and try to step past the boundaries of our universe, all you're going to end up doing is pushing the boundaries of our universe further out and increasing the expansion rate. But because you know our universe started from nothing within this area, you also know there's more universes, or the possibility of other universes. Just like there's life on Earth, and then there's trillions of different stars with hundreds of billions of trillions of different planets, and probably more. you know there's a possibility that there's life on other planets. Okay? Because area is limitless, and let's say the size of our universe is the size of our universe, and another universe is a Google flop universe distances away. That's the nearest one to us. Imagine how far we can expand before we start crossing into that universe and start interfering with it. Okay, but the way things start in that area, not a universe, in that area, is continued later.